Alright, what we're going to do today is we're going to finish our chapter 6, and then we may even start into chapter 7. If you remember, your next test will be on the 23rd. Correct me if I'm wrong, but I think that's a week from today. Is that right? Okay. So 1 week from today, we will have our last test in here. And that last test will, aside from your final exam, we'll cover all of chapter 6 and then whatever we get to in chapter 7. Okay? So, as far as chapter 6 is concerned, we got to this one. Remember, what we're doing is we are solving quadratics. And we talked about a couple of methods as far as solving as quadratics are concerned. We talked about factoring. We learned how to do that in chapter 3. And then we talked about the square root property, which we touched on a little bit in chapter 5, but then we extended it into our equations here in chapter 6. And then the other thing that we're going to do is we're going to learn 2 other methods to solve a quadratic today. Okay? The first one's called completing the square, and we did discuss this a little bit last time. So, completing the square, again, number 1, make sure your leading coefficient is 1, and that's key. Your coefficient, your leading coefficient has got to be 1 before you complete the square. And then what you're going to do is you're going to move your constants over to the right-hand side, of course, by solving an equation, taking the opposite. And then you're going to, and I've told you to put a big star next to this one, half of b and square it. That's how you're going to complete the square, and then you're going to factor and then solve using the square root property. Alright, so let's look at this thing in action. If I have x squared plus 8x plus 12 is equal to 0, the first thing you got to do is make sure your leading coefficient is 1. Well, it is 1. The next thing we're going to do is we're going to take this 12 and we're going to move it to the right hand side. So we're going to minus 12 from both sides. And so what we're going to have is we're going to have x squared plus 8x. Now what I do is when I minus 12 from both sides, I do plus a blank. And I explained that the last time we were in class. I explained that to you on Monday. Plus a blank means that we're going to complete that square. Okay, and we're going to make a perfect square trinomial. And it's always plus a blank. So now we're going to have is equal to negative 12 plus that exact same blank because we have an equation and we've got to keep it balanced. So if we add something on one side, you've got to add it to the other side. Now, to fill in that blank, that's where the half of b squared is going to come into play. Remember I told you your leading coefficient is a, your middle coefficient is b, and your constant is c. So let's take half of 8 and then square it. So half of 8 is 4, and 4 squared is going to be 16, and that's what goes in your blank on both sides. So now what you're going to do is you're going to factor this. Now this perfect square trinomial, it is a pattern. It's one of the patterns that we learned how to do in chapter 3. So it will factor into a binomial squared. In particular, it's going to be x plus 4, quantity squared. So like I said, it will factor. Is equal to, and over here, negative 12 plus 16 is going to get, or is going to give you 4. So we completed the square. Now what we're going to do is we're going to use the technique that we talked about Monday, which is going to be using that square root property. So remember, we need to get to this x. In order to get rid of this, or get to this x, we need to get rid of all this other stuff. So the first thing we're going to do is going to get rid of the square. The opposite of a square is a square root. And remember, anytime you initiate a square root, anytime you draw a square root, you have to use that plus or minus symbol. So on the left-hand side, the square and the square root cancel each other out. So you get x plus 4. On the right-hand side, the square root of 4, since we initiated it, is going to be plus or minus 2. Okay, make sure you use that plus or minus symbol. That's where your 2 answers are going to come from. So now what we're going to do is we're going to minus 4 from both sides. And remember I told you Monday, be careful with this. Because that negative sign goes with the 4, and the plus or minus symbol goes with the 2. Okay? Now, to figure out these 2 answers, and again we did this Monday, you're going to have negative 4 plus 2 And you're also going to have negative 4 minus 2. So we're going to get a negative 2 and a negative 6. So these are your two answers. A negative 2 and a negative 6. Okay? So, where are you going to use the completing the square? For my purposes on the test, when I give you the quadratic, all I'm going to do is say solve. I'm not going to say solve by factoring. I'm not going to say solve by using completing the square. I'm not going to say solve by using square root property. I'm not going to say solve by using quadratic formula. I'm just going to say solve. And so you get to pick and choose which method you use. So does that mean good? I don't have to know how to complete the square. If you're going into 112, you've got to know how to complete the square. Because day 1 of 112, you will do this multiple times. So make sure you know how to complete the square, or just kind of can remember. Bring it out of your cabinet, your filing cabinet in your brain to complete the square. All right, so let's try again. So to complete the square, again, the first thing you got to do is you've got to get that leading coefficient to be 1. Well, right now it's 2. So what we're going to do is we're going to divide everything by 2. Divide everything by 2. So if we divide everything by 2, we're going to get x squared plus x plus 4 is equal to 0. Okay? From here, we need to get that 4 over to the right-hand side, so we're going to minus 4 from both sides. And when we do that, we're going to have x squared plus x plus a blank is equal to negative 4 plus that same blank. Can you tell me what number goes in the blank? Well, you're going to do half of b. What is b in our new equation? 1, half of 1, and then square it. What's half of 1? And what's 1/2 squared? Okay, so you can get fractions in this. That's okay. We know how to deal with fractions. We have our calculators, right? Now, how in the world are we going to factor this? Well, in order to factor this perfect square trinomial, what you're doing basically, and we learned this in chapter 3, is you're going to take the square root of x squared, which is going to be x. You're going to match the first sign, which is going to be plus, and then you're going to take the square root of 1/4. Well, think about this with me. To get this 1/4, we had to square 1/2. So what do you think is the square root of 1/4? 1/2. All right, is equal to, in your calculators, do negative 4 plus 1/4. Negative 4 plus 1/4. What'd you come up with? Negative 15/4. Yeah, you're going to get a mixed number, but we don't want mixed numbers when we do this, so make sure you change it to an improper fraction. Mixed numbers are not a good thing when you're dealing with radicals. You do want an improper fraction, so negative 4 in your calculator, not that I don't trust you. Negative 4 plus 1/4. And in the calculator, I didn't do that right. Yeah. In your calculator, it's going to give you a mixed number. Just go ahead and use your button that changes it to an improper fraction, which is going to be negative 15/4. Okay, so completing the square is over. The next thing you're going to do is solve by using the square root property. So we're going to take the square root of both sides. Well, on the left-hand side, these cancel each other out, so you're going to get x plus 1/2. On the right-hand side, we've got some work to do. We need to go back into chapter 5 and figure out how to do this. Any suggestions? Well, you can do square root of negative 15 over the square root of 4. That's fine. Now what? You can, but it's a little bit easier than that. There you go. So you have the square root of negative 15 over 4, or square root of negative 15 over 2. Square root of 4 is going to be 2. We got one more thing we need to do. Can you take the square root of a negative number? We learned how to do this on Monday. Can you take the square root of a negative number? No. What do you need to do? Anytime you see that negative under there, pull out an I. So you get I square roots of 15 over 2. So you will get complex numbers with these. Some of these you can get complex numbers. That is a possibility. Now, because we initiated that square root, you do have to put in that plus or minus symbol. So it's plus or minus I square root 15 over 2. Okay? So now all we have to do is minus 1/2 from both sides. And this is where it gets kind of crazy. So watch what I'm going to do. You're going to have x is equal to negative 1/2. That's this one. Negative 1/2. Remember, your plus or minus symbol goes with your radical. So plus or minus I square roots of 15 over 2. And this answer is fine with me. If you put your answer on this answer on your test next week, that's fine with me. But if you're working through your study guide and you look in the back of the book, or if you see something like this on your final exam, you won't see the answer like this, because your final exam is going to be multiple choice. What they're going to do, and I'm not going to require you to do this for this coming test, but what they're going to do is, since you already have a common denominator, they're going to put these two fractions together. So your numerator is going to be negative 1 plus or minus I square roots of 15 all over 2. Okay? And that's what they do in the book, and that's what they're going to do on the multiple choice test. But for our test coming up next week, if you want to leave it like this, that's fine. Or if you want to combine it, that's fine as well. And I'll just be honest with you, if I ever have to solve a quadratic, rarely will I use the completing square, unless I have to. If I have to, then I will, but if I don't have to, I ain't going to do it. Alright, so let's look at this one. So this one is a booger within itself because that middle term is not negative, but odd. So when we take half of it and square it, we're automatically going to get a fraction. Yay. So our leading coefficient is 1, though, so that's a good thing. So we don't have to divide to get rid of that leading coefficient. So what we're going to do is we're going to move that 3 over by adding 3 to both sides. And now we're going to fill in that blank. Half. My brain. Half of 5. And then square it. What's half of 5? 5 halves. Half of 5 is 5 halves. And then if we square it, we're going to get 25 over 4. So that's what's going to go in the blank. 25 over 4. Well, I mean, you can put that negative sign in there, but when you square it, it's going to go away anyway. All right, so if we factor this, it's going to factor into a binomial square always. That's just memorizing your pattern. Square root of x squared is going to be x. Match that first sign, which this time is negative, so don't mess that up. So what's the square root of 25 over 4? 5 over 2. You're just going to go right back to here. Go right back to where you started from. All right, is equal to, and if we do 3 plus 25 over 4, you're going to get a mixed number again, so let's change it to 37 over 4. 3 plus 25 over 4 is 37 over 4. All right, so now we've got to get to that x because we're going to solve. So to get to that x, we got to use our square root property, so we're going to take the square root of both sides. So if we take the square root of both sides, we're going to get x minus 5 over 2 is equal to plus or minus the square root of 37 over 2. See what I did? Okay. The only thing left to do is add 5 halves to both sides. So we're going to get x is equal to 5 halves plus or minus the square root of 37 over 2. And again, like I said, this answer is good for me, but in the book and on that multiple choice test or final exam, they'll go ahead and put them together. All right, so before we move here, All right, so the last method that we're going to use in order to solve a quadratic is called the quadratic formula. This quadratic formula will work for any quadratic. So if you don't ever want to factor again to solve a quadratic, you don't have to. If you don't ever want to use the square root property, you don't have to. If you don't ever want to complete the square, you don't have to. This quadratic formula will solve every single quadratic you come across. Every single one. Now, the key, however, is you've got to have it in general or polynomial form. It's got to look like your general quadratic before you can use the quadratic formula. So in other words, if it looks like this or this is not our general form, is it? A couple of things. Number one, these are not set equal to 0, so that tells me it's not in general form. Number two, I see parentheses, so that tells me it's not in general form. So if you come across one that looks like this, you're going to have to do some algebra to get it in general form before you can use the quadratic formula. Okay? So I'm not lying to you. You can use the quadratic formula to do every single one of these. It's just some of them you'll have to do some work to in order to use the quadratic formula. Okay, so what is the quadratic formula? First of all, let's remember your leading coefficient is a. It's going to be your x squared. It's going to be a. Middle term is b, and last one is c, and it's got to be set equal to 0. So what we're doing, remember I told you when we started solving these quadratics, when you graph a quadratic, and you'll do this in 112, when you graph a quadratic, you are going to be graphing a parabola. And that parabola is going to cross the x-axis in two spots, possibly, most of the time. Sometimes it will sit on the x-axis, which means you're only going to have one answer, and sometimes it won't even go through the x-axis, which means you don't have any answers, or it's complex. So what we're doing is we're trying to find the two coordinates that the parabola crosses the x-axis at. And so that's why you see x equals, because these are going to be x-intercepts. Everything that we're finding, even those two answers over there, those are x-intercepts. And so that's why it says x equals the opposite of b. So you're going to find out what this number is, and you're going to take the opposite sign. No variables needed, okay? So you're going to take the opposite of b. Plus or minus is that same symbol we're using when we were completing the square. Square root of b squared minus 4 times your a times your c, and then all of it. And this is where some people lose it. Every bit of that is over 2a. Not just the radical form, but every single bit of it is over 2a. Okay? So, your quadratic formula. Write it down. Make sure you know it. Hopefully you've copied this because you're fixing to use it. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. Make a little jingle out of it. Make a little song out of it so you can remember it. Opposite of b plus or minus square root of b squared minus 4ac all over 2a. No variables will be used. Pure numbers, which means pure calculator work. Pure calculator. Okay? So, here we have it. We're going to have x equals. Again, this is a is 2, b is -1, and c is -3. So we need the opposite of b, which is going to be what? +1, plus or minus the square root of b squared, so you're going to have -1 squared, minus 4 comes from your formula, times a, which is 2, times c, which is -3, all over 2 times a, which is 2. So you see, no variables, just straight numbers. You're just plugging them straight in. Okay, so from here, we just need to do some math. Now this 1, that opposite of b, that number out there, you're not going to do anything with it until the very, very end. So just bring it along. Plus or minus. What's underneath this radical? That's what we're going to do first. Okay? -1 squared, of course, is 1. And now watch. I don't want you to lose this. I don't want you to get confused on this, okay? This -4 times 2 times -3, put it all in your calculator at one time, or put it all in your head at one time. -4, that's going to be a -4 every single time. -4 times 2 times -3. What are you going to come up with? A positive 24. All over 2 times 2 which is going to be 4. Do you see how this is going to shape up? Can you do a little bit of forward thinking? A lot of you are writing, so you're continuing on. Good. So x is equal to, watch this, 1 plus or minus the square root of 25 over 4. Well, that looks even better, doesn't it? Because, what is the square root of 25? Okay, so listen to me and remember this, all right? At this step right here, if you can take the square root of this number, or if you can rationalize it or whatever, I need you to keep going. If, however, you can't take the square root and you can't simplify this in any way whatsoever, just stop and don't go any farther, okay? But since we can simplify this, we're going to keep going and we're going to come up with good real numbers. So watch what happens. You're going to have 1 plus 5 over 4, and you're going to have 1 minus 5 over 4. That's your plus or minus symbol. Just split it up. So on the left-hand side, 1 plus 5 is going to be 6 over 4, which that's going to reduce to 3 over 2. And then 1 minus 5, which is going to be negative 4 over 4, that's going to be negative 1. And there's your 2x values. So this parabola crosses the x-axis at 1 1/2 and negative 1. Okay? Quadratic formula. And like I said, if it goes all the way out, it's easy, really, because you get those numbers. Just be careful with your signs. Please be careful with those signs. All right, let's try this one. X equals what? You tell me. Negative 4. Keep going. Plus or minus. Square root. 4 squared minus 4 times 1 times negative 1 all over 2 times 1. Very good. Opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, so let's do some math. We have negative 4 plus or minus. Don't even mess with that. Even the 2 times 1, I mean, you can go ahead and do that, but you're not even going to mess with that with the end. What's underneath the radical, that's where your real work is going to be consumed. Okay? So 4 squared is going to be 16. Negative 4 times 1 times negative 1. What do you think? Positive 4. So we have negative 4 plus or minus the square root of 20 over 2. Now, this is where you need to stop and think. Can you take the square root of 20? No, but can I simplify it? Can I rationalize the square root of 20? This is where your chapter 5 comes into play. What is the square root of 20 going to be? 2 root 5, very good, over 2. This is where your chapter 4 comes into play. Can I reduce this fraction at all? Look at all your whole numbers. Look at all your whole numbers. Is there one number that will go into every single one of those whole numbers? 2. So we can reduce every single one of these by 2. So this is going to go to 1, this is going to go to 1, and this is going to go to negative 2. So your complete and final answer is going to be negative 2 plus or minus the square root of 5. Because all those ones, I mean, you can write them if you want to, but you don't have to. Now, let's just say that you have a multiple choice test. And one of those choices was negative 2 plus square root of 5, comma 2, negative 2, no, I'm sorry, 2. No, negative 2. Negative 2 minus the square root of 5. What if that was one of your answers? Would you pick that answer for your choice? Yes, that is the answer. It's just comma separated, okay? Those who do Math 100 online, they have to actually enter their answer this way. It's just comma separated. So if your multiple choice test has your answer looking like that, that is your answer. All right, one more time. We have x equals, you tell me. Positive 2, opposite of b, plus or minus negative 2 squared, square root of negative 2 squared, minus 4 comes from your formula, times 3 times 5, good, all over 2 times 3. All right, I'm going to give you a 30-second head start. Do some math. Do as much as you can. How do we do? All right, so getting down to this point, you should be able to do. That's just pure calculator work. 4 minus 60 is going to be a negative 56. Now, this, again, is where most of your attention is going to be spent. Square root of negative 56, it just takes you back to chapter 5. Can you simplify or rationalize the square root of negative 56? Well, I worked in my calculator and figured out that 4 will go into 56 14 times. And so I see that negative. I'm going to pull out an I. Square root of 4 is going to be 2, and you can't do anything with 14. From here, I recognize that the 2's and the 6 have a 2 in common. So I reduced everything by 2. Now, word of caution here, and you may want to make a note in your notes. When you cancel something out doing these problems, it goes to 1. So on the previous problem, I didn't write those 1s because I didn't need them, because look, the 1 was here with the radical, so I know that that has a coefficient of 1. And the 1 in the denominator I don't need because it's over 1. But this one I need, okay? Because it's not a coefficient and it's not a denominator. I do need that. All right, so when you cancel that one out, it does go to 1. So you have 1 plus or minus I squared is 14 over 3. Please don't put I squared is 14 over 3. That's not the answer. You got to have that 1 in here, okay? So just to be on the safe side, if you want to leave your 1s where they are, that's fine. But just make sure you understand which ones you need and which ones you don't need. Okay. Let's work on this. Look at the problem on the left. We haven't done this since chapter 4. Haven't done this since chapter 4. Can you tell me how to begin to solve this equation? It's an I hear it. It's an equation that has fractions in it. What do? Anytime you have an equation with fractions in it, what do you want to do? Get rid of the fractions. How? What is the common denominator? 3n. Good job. Very, very good. So let's multiply every single one of these by 3n. 3n times n is going to be 3n squared. 3n times negative 2 over n. The n's are going to cancel out, and you're just going to get a negative 6. 3n times negative 7 over 3. The 3's are going to cancel out, and you get a negative 7n. Okay? Now we're back to chapter 3. See how it all builds on itself? What do we need to do? Yeah, this is your quadratic. So you got to get it set equal to 0. So we're going to have 3n squared minus, put it in descending order, plus 7n. Minus 6 is equal to 0. Just adding 7n to both sides. Now you have options. You have 4 options, in fact. You can either try to factor it, you can try to use square root property, which we don't have parentheses, so that option kind of goes away. You can complete the square, but it's going to be ugly. Or you can use a quadratic formula. So, if I'm sitting at my desk and I'm working a test out and I have to do this, either 1, I'm going to try to factor it, or 2, I'm going to use the quadratic formula. So this one, if we started to factor, what would we do? Bottoms up. Right, you would bottoms up. And if you don't want to factor, you never learned how to do bottoms up, go ahead and start the quadratic formula. Go ahead and start the quadratic formula if you want to. But this one will factor, I think. So I'm going to go ahead and do bottoms up. So we're going to have n squared plus 7n minus 18. And then if I factor that, I'm going to have n plus 9 and n minus 2. So then I have to turn around and divide that 3 back out. So I'm going to have n plus 3 and then 3n minus 2. And then if you take each one of those and set them equal to 0, you're going to get n is equal to negative 3 and n is equal to 2/3. And if you use the quadratic formula, you should come up with the exact same thing. If you use the quadratic formula, you should come up with the exact same thing. So again, factoring is a good thing to know, but if you just don't know how to factor, or if you just hate it that bad, use the quadratic formula. You should come up with the exact same answer. I think, how many of you are using the quadratic formula right now? You need a little bit of time? Okay, so let's look at the one on the right. What do you think? This goes back to chapter 4. How many fractions do you see? 2. So if you have one fraction set equal to another fraction, do you remember what to do? Very good. Cross multiply. So let's go this way first because that's going to be the hardest one. N minus 2 times n plus 5. That's the full method. Okay, so go ahead and start pulling that out. N minus 2 times n plus 5. Go ahead and start pulling that out. And then set that equal to the other way, 3 times 4, which is going to be 12. So when you pull that out, you should have n squared plus 3n minus 10. And that's going to be equal to 12. Alright. Let's get this in general polynomial form. So let's minus 12 from both sides. So we're going to have n squared plus 3n minus 22 is equal to 0. And I don't think that one's going to factor, so I'm going to choose to do the quadratic formula. So I think y'all can do this. Alright, 97 is prime, so you're just going to stop there. 97 is prime, so you're just going to stop. Alright, any questions on the quadratic formula? Do you think you need to work some extra problems using the quadratic formula, or are you good with it? How many of you use the quadratic formula on both of these? Obviously the one on the right you had to, but the one on the left? So we're good? Okay. So now let's do some applied problems. Remember on your final exam, the last few problems are going to be applied problems. If you've already looked at the final exam study guides, you know that there is a whole section applied or dedicated to these applied problems. Most of the time, every time I give you a word problem on the test, either you skip it or you just put down a number. Try. At least try. Okay? So let's look at this. Find 2 consecutive odd whole numbers. Do you remember the formula for that? 2 consecutive odd numbers. If the first one's 3, what's the next one going to be? 5, but if we don't know them, the first one's going to be n, and what's the next one going to be? N plus 2, right? From 3 to 5, you add 2. Find 2 consecutive odd whole numbers such that the sum of their squares. Sum means what? Sum means what? Addition. Squares mean we're going to square them. Is your equal sign 290. So just pick it apart. Find 2 consecutive odd whole numbers such that the sum of their squares is 290. So basically what we're looking at is n squared plus, and I'm going to go ahead and pull this out, n plus 2 quantity squared is going to be n squared plus 4n plus 4. Just pull it out. Is equal to 290. So what are we going to do from here? Combine like terms. So we have 2n squared plus 4n plus 4 equals 290. What do you want to do from here? Minus 290 from both sides, right? So it's equal to 0. Good. So we have 2n squared plus 4n minus 286. What do you want to do? You choose. We got to find the 2 numbers, which means we got to solve for n. What do you want to do? You want to divide everything by 2? Okay. We can divide everything by 2. That sounds good to me. Makes it a little bit easier anyway. So we're going to have n squared plus 2n minus 143 is equal to 0. Now what? What? What are you going to do? Seriously? Quadratic formula. Okay. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Alright, so we have x equals negative 2 plus or minus the square root of 4, and I have no idea what that is, plus 572 all over 2. Now, let me give you a hint here, okay? I know that I should be able to simplify that square root. I know that I should be able to take the square root of the number that I'm fixing to get. The reason being is because of this word right here. You should get whole numbers as your answer. And that came from the problem. Alright, so we have negative 2 plus or minus the square root of 576 over 2. So what is the square root of 576? So we have x is equal to negative 2 plus or minus 24 over 2. Find those 2 numbers. Find those 2 numbers. However you want to do it, just find them. Oh no. If you square them, you're going to get positives. Thank you. That was driving me nuts. Okay. And to think, you're the one that misses out on all of them. Alright, so let's try another one. A number is equal to, a number, we don't know what it is equal to the square root of the sum of the number and 6. What is the number? A number is equal to the square root of the sum of the number and 6. What are you going to do now? Yeah. Square both sides. So we're going to have n squared is equal to n plus 6. What are you going to do now? So you have n squared minus n minus 6 is equal to 0. Is that going to factor? N minus 3 and n plus 2. So n is going to be 3 and n is going to be negative 2. But look at this. It says find the number. So we only one of these is your answer. So watch this. If I plug, you got to test them. If I plug 3 in, 3 is equal to the square root of 3 plus 6. So 3 is equal to the square root of 9, so 3 is equal to 3. That checks out. But what if I plug negative 2 in? So the answer is 3. Why can I not take the plus or minus? Did I initiate the square root? No, the square root's already in the problem. So I didn't initiate it, so you're not going to take the plus or minus. Okay? So that negative 2 doesn't work. Good deal. Okay, last thing we're going to do in chapter 6, quadratic inequalities. Write down these steps. Make sure you have these. If you want to take a picture of them and write them down later, you can do that too. Just make sure you have these steps. If you have my PowerPoint, you should already have them. So, when you're solving a quadratic inequality, the difference is between an equation and an inequality. An equation, you have 4 techniques to solve that equation. Okay? You have the factoring, you have the square root property, completing the square, and the quadratic formula. That's for an equation. If, however, you have an inequality, you don't have a choice. These are your steps. Okay? If you have an inequality, you're going to use the factoring method first, which means it's got to be set equal to 0 or inequality to 0. When the problem gets down to the zero product property, you're going to find the numbers that will make a problem equal to 0. So we're going to take care of the equal part first. Okay? These are going to be your 2 starting points. These are going to be your 2 starting points. Because if you remember from chapter 2, when we're dealing with inequalities, you don't just have 1 or 2 solutions. You have a whole bunch of solutions. Well, with these, you're either going to have, do you remember ands and ors? Compound statements, you remember disjunctions and conjunctions, that's what you're going to get here. Okay, so either your graph is going to converge or your graph is going to go apart. So you're going to graph the 2 numbers that you found in step number 2 on a number line. This is going to give you 3 sections. And what you're going to do is you're going to pick a number out of each of those 3 sections and plug it into your original problem. If it comes out true, then that section is going to be part of your solution. If it's false, then that section is not part of your solution. Okay, so again, here are your steps. Factor, those are going to be your starting points. Graph, choose numbers out of your sections. Whichever section makes it true, that's going to be your part of your solution. Now, either one section could be true, all 3 sections could be true, just 2 of them could be true, or none of them could be true. These are all possibilities. Okay, no solution, infinitely many solution, a disjunction, or a conjunction. 4 different possibilities. So let's look at this. We have x squared plus 3x minus 54 is less than 0. So the first thing we're going to do is we're going to factor this. What's 2 numbers that we can multiply together to get negative 54 but add together to get 3? Yeah. So we have a positive 9 and a negative 6. So your starting points, again, take these and set them equal to 0. Why did I put 3? Alright, so let's draw a graph. We're going to get negative 9 and we're going to get 6. So this is where your solution is going to come from. Okay? Everything up to that point, you know how to do. You should know how to factor. You should know how to continue to solve and come up with two possible solutions. So you have -9 and you have 6. Now, I will tell you this, and this is something that we learned in Chapter 2. Since this is just less than, not less than or equal to, it's just less than, you're going to have, do you remember the open circles or the parentheses? Okay, cannot be equal to -9 and 6. So now what we're going to do is we're going to choose numbers. Give me a number in the interval to the far left. Any number. You have an infinite selection here. To the left. -15. Give me a number, please. Choose a good number between -9 and 6. -9 and 6. 0. 0 is always a good choice. And then a number to the right of 6. 8. Sounds good. Okay. So now what we're going to do is we're going to test all three of those numbers into our original problem. So we're going to have -15 squared plus 3 times -15 minus 54. And we want that to be less than 0. We want it to be less than 0. So let's put that in our calculator. We have -15 squared, which is going to be 225. And then 3 times -15 is going to be a -45 minus 54 less than 0. So if we have 225 minus 45 minus 54, you get a positive 126 less than 0. True or false? That's false. So this, none of those numbers are solutions. None of them. Just mark them off. Okay? Let's try 0. If I have 0 squared plus 3 times 0, and you'll see why I like 0, you get a -54 less than 0. True or false? So this is going to be part of your solution. So let's try 8. 8 squared plus 3 times 8 minus 54 less than 0. Put that in your calculator, and you already know, just by looking at it, you get a positive number. True or false? So that's not a possibility. So, do you remember how to write interval notation? Do you remember how to write this? Let me sweep out the cobwebs for you. Parentheses, -9, 6, close. You remember that now? A little bit of cobwebs and it's out of the way. We haven't done this since Chapter 2. Do you understand why these are parentheses? Why we cannot equal -9 and 6? Because you don't have that line underneath there. Remember that? If you had the line underneath there, what would it be? Instead of parentheses, you would have brackets. You'd have brackets. Good. Okay, let's try this one. What's this going to factor into? +7 and -3. So what are going to be our starting points? -7 and 3. All right, give me some numbers. Number to the left of -7. In between -7 and 3. And to the right. I heard 4 and 5. We'll just go with 4. All right, so let's test these. So we're going to have -10 squared plus 4 times -10 minus 21 less than or equal to, greater than or equal to 0. So we're going to have 100 minus 40 minus 21. The fact that you're going to have a positive number tells me that's true. 39 greater than or equal to 0. That's true. So this is good. What happens if we plug 0 in? Get negative 21. True or false? So that's not going to work. So let's plug 4 in. What do you think? Yeah. All right, so this is a disjunction. This is a disjunction. This graph goes away from each other. Do you remember how to write this? This is going to be negative infinity. What always goes with your infinities? So you have parenthesis, negative infinity all the way to what? Negative 7. Can we include negative 7? Yes. Why? Because you can be equal to that line right there. That's the bracket. What goes in between these with a disjunction? It's a U, it's the cup, U, whatever. Alright, and then we're going to pick back up at 3 and go all the way to positive infinity. Good. Seriously. Okay, let's try this one. This is scaring me. I don't even think this is going to be a quadratic, but let's try it. Okay. So we're going to have 3x minus 12 is less than or equal to x plus 2. Well, what do you see? What do you notice? What do you notice? What's different from this to this? But does it have to be set to equal to 0? It's not a quadratic. It's not linear. Or it is linear. This is not a quadratic at all. You can solve this. Minus x from both sides. So you have 2x minus 12. So don't overthink this. It doesn't always have to be a quadratic. I don't know why this problem is even in here, but we'll go with it. That's chapter 2 stuff. We need to fix that. Do it. I took 1 out, I know. Alright, there's your study guide for chapter 6. Again, let me pause.